Alright, this video is about arithmetic series. Okay, using what we did with summation, we're going to talk specifically about arithmetic sequences and series. Okay, so remember what an arithmetic sequence is. It's a sequence whose consecutive terms have a common difference. And you can look at the two terms and either they're adding the same value or they could be subtracting the same value. We call that value D. Okay, a series is the sum of those consecutive terms. Okay, and we're going to do partial sums today. But I want to make sure you know the difference between a sequence and a series, all right? So the sum of a finite and arithmetic sequence, all right? And the fact that you're taking a sum makes it a series. So you're going to use this formula, and this is on the card. So pay attention to what it's saying. This is saying the sum of n terms, and then the problem will tell you how many terms you're adding up. And here's your n again, equals that n divided by 2, times what's happening in the parentheses. First term times the nth term. Now, if you recall, back a week or so ago, we found the nth term, and we said for an arithmetic sequence, the nth term was a sub 1 plus n minus 1 times d. This is on the card. So you're going to need to use this formula to find the a sub n, plug it into the formula, and then you've got it. So the first thing you're going to have to do when you solve one of these is to find the expression. Okay, that's the equation. Find the nth term and then plug it into the summation formula. Okay, this guy. So for example, number 1, find the 50th partial sum of the sequence. All right. So the first thing I need to do in order to write my expression here, I need to know what d is. I know a sub 1 is negative 6. And I know that n is, in the problem is going to be 50. But I need to know, what is this formula right here, the expression? So a sub 1 is negative 6. Well, what is d? So I look between the terms. Negative 6 to negative 2. What's happening? I'm adding 4. What's happening from negative 2 to positive 2? I'm adding 4. And here I'm adding 4. You should see a pattern. This tells me that d is 4. So to find my expression, I'm going to take negative 6 plus n minus 1 times d, which is 4. And I'm going to solve this. Negative 6 plus 4n minus 4. So a sub n equals 4n. Negative 6 minus 4 is negative 10. So there's my expression. Now I need to find the nth term. Well, what is n? 50. So a to the 50th term is 4 times 50 minus 10. Well, that's 200 minus 10, also known as 190. So I know a to the 50th is 190. Now I can use this formula. So I want to find the sum of those first 50 terms. So I'm going to do 50 divided by 2 times a sub 1, which was negative 6, plus a sub n, which is 190. So 50 over 2. Negative 6 plus 190 is 184. So I can put that in my calculator. And I get 4,600. It's a quicker way to get the sum of a series. Okay? So this would be my answer. 2 steps. You had to find the expression, find the nth term, and then finally you could put in the formula. I guess that's 3 steps. But 3 steps there. Here they are. Okay? So let's try another one. What if they give it to you like this? Well, the good news is you don't have to find the expression. Here's the expression. It's already done. So step 1 is done. To find the nth term, all I have to do is plug in, plug in the 27. Okay? So 3 times 27 plus 1. Figure this out, okay? So 3 times 27 plus 1 is 82. So a to the 27th, the 27th term in the sequence is 82. Now I can use this summation formula. So S, the sum of 27 terms, is going to equal 27 over 2. A sub 1, well, what's the first term in the series? Well, if I put in a 1, I get 3 plus 1, which is 4. So that's a 4, plus a sub n, we found was 82. And then I put this in my calculator. 27 divided by 2 times 4 plus 82 is 86. So I get 1161. And that is the sum of that series. All right? So there's two types of problems. One where you're going to have to find the expression, and one where they give you the expression in sigma notation. All right? Hopefully that helps, and we'll see you in class.